what happens when we have a rational number minus an irrational number, or let's say vice versa, irrational number minus rational number. Let's find out. So let's write down some irrational numbers. We know square root 2 is 1.414 and it goes on forever. Similarly, square root 3 is 1.732 ... it goes on forever. Now I'm using this as just some examples. You can also try out with square root 5, square root 7, so on and so forth. So what we are going to do is we are going to just take some random rational numbers and random irrational numbers and find out really when we actually carry out these operations, what do we get. So let's say we want to do something like square root 2 minus 1. So square root 2 is an irrational number and we know 1 is a rational number. So what happens when we actually do the subtraction? So square root 2 is this number, right? So let's write it. 1.414 ... minus, we have 1 over here, right? So we can write this 1 in this fashion. When we do subtraction, the decimal part, what happens to that? Well, it will be simply 414 forever, like that, right? So 414, and whatever is in here will just come down. And 1 minus 1 in this side will be 0. So our final answer, square root 2 minus 1, is this number. Now, is this number rational or irrational? This is such a number whose decimal expansion is non-terminating, non-repeating. Why non-repeating? Because square root 2's extension does not, decimal part does not terminate, does not repeat, right? So this will be the same. So this will be an irrational number. Let's take a look at one more example. How about we do this time maybe square root 3 minus 1. What happens then? Again, we have taken two irrational numbers. So square root 3 is this number here. So we have 1.732, and this will go on, minus 1 again, right? So here what do we see? So again, the decimal part will come down exactly like this, and it will go on forever, and this part will be 0. And this will be again another irrational number. Let's take a look at some more examples. This time let's try, how about we do 2 minus square root 3, let's say. Let's try this number out. So this will be, square root 3 is 1.732. It will go on like this. And minus, we will have 2. We will get like this, right? So because the number 2 is actually, we did it the opposite way. We should have actually written it. This is my bad. So let's just do it again. So let's write it over here. So this will be 2 like this minus, right, 1.732 like this. So now if we were to carry out this subtraction, what do we get? I think here we basically the other way. We did this one. Maybe we can try to do this after we finish this. So if we were, so this is, we are solving here, is basically 2 minus square root 3. That's what we are doing here, right? So to find out, so let's try to actually carry out this subtraction. So because the number does not end, this number does not end, right? The decimal part, that is. Can we actually carry out the subtraction? So we actually cannot. Because if this were any normal decimal number, right? Let's say, for example, if it were 2.00 minus 1.73. Instead of 732 forever, if we had just this, what will be this answer? So we will take 1 from here. This will be 10. 10 minus 3 is 7. 9. 9 minus 7 is 2. And we will be left over with 1. 1 minus 1 is 0. So our answer will be this, which is clearly a rational number, because the decimal extension, the decimal expansion, it has terminated, right? But look at in this example, because the 732, this part goes on and on and on, because this is square root 3. When we actually carry out the subtraction, our final answer will be, it will be 0 point something something something, and this will keep going on and on and on, right? So quite simply, just by looking at it, what we can say, so this will be probably 9 here. So 9 minus 2 will be 7. 9 minus 3 will be 6. 9 minus 7 will be 2. So we will get basically 0.267 dot 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 dot. So again, we will get an irrational number, right? So what we see is whenever we have, you know what, let's take a look at one more example before we actually wrap up. How about we try to do something like this? Let's say we want to do maybe square root 3 minus, say, 2 by 5. So 2 by 5 is a rational number. This is an irrational number. So what happens here? When we have something like this, first we are going to convert the rational number to the decimal form, right? So how do we do that? So we just simply have to divide. So we divide 2 by 5. So 0.0. So 5 fours are 20. The remainder is 0. So that means this, let's write it over here. This is square root 3 minus 0.4, right? So square root 3, let's write this 1.732 like this, minus 0.4, and we can write zeros here. So if we actually carry out this subtraction, we will notice that from the second decimal place onwards, right, second, third, fourth, because here we have all zeros, so whatever we have over here will come down straight here, right? So let's write the decimal here, and the second place of decimal, so we will have 3, 2, so on and so forth. So whatever we have here will come down, and for the first decimal place, 7 minus 4 will be 3, and here we will have 1, right? So the number that we are left with is 1.332 dot 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 dot, which is non-terminating, non-repeating. So again, we get an irrational number. So whenever we have a rational number minus irrational number, or vice versa, irrational number minus rational number, we will always get an irrational number.